Hello, welcome back. So last night I posted the solutions to exercises 1 and 2. Today I'm going to continue on to exercise 3. Just a couple of announcements. You have a quiz tomorrow. It'll be through Blackboard. And I have office hours today from 1 to 2. So let's just dive right into the exercise. The following table provides the short-run production function for K's hair salon. K uses only two inputs, labor and capital. Well, let's look at labor and capital. And why is this the short-run production function? Well, you can see capital is fixed. And when you have one of your inputs fixed, that's implication for the short-run production function. And then that implies that the variables are labor. So some combination of labor and capital gives us number of stylish haircuts. Labor is priced at $20. Oops, we don't want to cross it out. We want to highlight it. Sorry, some technical difficulties. Where is my pen? Pen, come back. Here we go. Sorry about that. So the price of labor is $20 an hour. And the price of capital is $50 per unit. So given this, we can come up with our cost for each of these things. So take this thing here and multiply by 20, and you'll get the following numbers. Okay? And 10 times 50 is 500. The reason I'm talking about it now is so we don't forget in case it's asked in a sub-problem of this exercise. Okay? And we can get our total cost by adding the variable and the fixed. Good. So far, so good. So we have some analysis going on here. Here, we want to complete the following table. Well, we found our fixed cost, we found our variable cost, and we found our total cost. So fixed is 500. And variable is this. We found it in the last slide. Then we can add the two. And next we need to figure out what is our average fixed cost, average variable cost, average total cost, and our marginal cost. Well, remember the marginal cost is the change in total cost per change in quantity. Well, in this case, remember this is our quantity column. These two help us get our quantity column. Now, how do I get these average cost over here? Well, by definition, average total cost is just taking your total cost and divide by quantity. So whatever the quantity you have at the moment. Just a quick note, since the quantity here is 0, we're not going to fill out anything for this row here because dividing by 0 is not possible. So total cost, though, is equal to fixed plus variable costs divided by quantity. And that's just telling us that we just need to add our average fixed cost to our average variable cost, and we'll get our average total cost. Okay, great. So I'm just gonna do some arithmetic here. I'm gonna copy this and apply it to an Excel sheet. This is just adding these two together. This is kind of a little wonky. Well, we know how to get marginal cost. It's the change in total cost divided by the change in quantity. So 28 minus 15 . So we have our marginal cost. Now we want to figure out these things. Well, to get our average fixed cost, remember it's taking your, well, we don't want to start there, so let's escape. It's taking your fixed cost, dividing by quantity. So in this case, 500 divided by 15 gives you 33.333. And you notice that the fixed cost doesn't change, hence why it's called fixed, but quantity is increasing. So taking the same number divided by bigger numbers gives you smaller numbers. And then here, you can just take your variable cost and divide by the quantity. Notice something, that the numbers from the average variable cost are pretty similar to the marginal cost. And then if you take the two and add them together, and you get your total variable cost. Now I want to do something real fast. So if we take your total cost and divide by quantity, you'll get the same thing. So you could either take in these numbers and divide by Q, or add these two together. Okay. So far, so good. Now, it wants to know, does the marginal production function exhibit diminishing marginal returns to labor? Well, I made an MPL column. And remember what MPL is saying, the change in quantity, so 15 minus 0, divide by the change in hours of work. So for every additional hour from 10 hours, you're expected to give an 1.5 haircuts. And if you keep doing these changes, so taking the difference here, comparing it to the difference here, and so forth, you see the numbers are getting smaller. Well, that's exactly the definition of diminishing returns. It's still positive, but you're just getting less and less benefit. And so the answer here, let's see, I want to make it really stand out. We're even going to draw a smiley face so you understand that we're happy and you know it. Clap your hands. And so that wraps up that problem. The next problem is graphing total cost and then graphing everything else, all the other costs. So average total, variable, fixed, marginal. So what I'm going to do is use my spreadsheet instead of doing it by hand. And so our x-axis is going to be this quantity of haircuts, and our y-axis is going to be this other jazz. So let's see if I can get a nice graph. And it looks like I can. See, this is going to make it look weird. So what I'm going to do is let's get rid of total cost and make it its own graph. I didn't want that graphed. Perfect. Let's make it look fun. We might as well have fun if we're going to be doing some math. That's as good as it gets. So I'm going to explain these in just one moment, but let me just get the graphs here. And let me get the total cost. So I'm going to move this fella down here. And let's graph this. Again, I'm not just about education, I'm about entertainment. We'll give it this nice green color. And so let's put it here. So as you can see, as number of haircuts increases, your total cost will increase. So that's not a surprising graph right there. Let's see what's happening here. Now I want to zoom in. So what I'm going to do, let me just fix one more thing, because the graph didn't give me what I exactly wanted. So this and this. Perfect. Let's get rid of that. Give it that nice dark color. I'm just trying to make it look pretty, so while you're listening to me yammer, it's much more interesting. So, perfect. So let me just take this and not put it here, but let's put it on its own page. Perfect. So we can see that this blue curve is our average fixed cost. The orange is our average variable cost. And you take the two things together, add them, and you'll get your average total cost. And then this bright yellow line is our marginal cost. And so that completes the exercise 3. Eventually, we're going to talk about the relationship between average total cost and marginal cost, because we're going to be interested in doing some more analysis on how we can get our supply curves in the future. But that's a story for a different day. So that wraps up the lecture on chapter 11. Okay, see you soon.